Okay, so I'm recording this lecture to make sure to see how much material I can finish tomorrow. So first, before I start the lecture, I have a few announcements to make. First of all, the student evaluations are due today, basically Friday. And I really appreciate if you guys can fill them out and then evaluate me and Professor Still, especially me, because I want to see what I can do differently and which part of what I was doing was good. So if you like extra credit assignments, if you like extra office hours, if you like makeup exams, if you liked study guides, anything that you liked, just reflect, and anything that you didn't like and you don't want to see further, just reflect on that too, so I make sure that I won't do that next semester. So give me feedback, I really appreciate that. And then for your final exam, again, as I said, your final exam would be next week on 17th, and it would be from 10:15 a.m. So make sure that you come on time, and it would be just like your class location, so JEB 104. And I'm going to post all the extra credit assignments, all the quizzes, all makeup quizzes, all makeup exams, so you have all those materials. So make sure to study those well along with the study guides. For chapter 10, I am going to only ask from the study guide to make your life easier. And also for chapters 1 through 4, I am going to only ask from the study guides. So theoretically, if you study these 5 chapters really well, you can get like at least 50 out of 100, basically 100 out of 200. And your final exam is out of 200. And you had like exam 1, quiz 1, exam 2, quiz 2, exam 3, quiz 3, right? So you had like 4 exams, 4 quizzes, plus your final exam is like 800. I'm going to, grade all your extra credit assignments, put them separately in BB Learn, and then add them together. So if you did like all the extra credit assignments and everything, so I'll add that to this. Any question about anything that I said right now? And also, I'm going to design an exam really similar to your final exam, and I am going to post a really similar exam to your final exam in BB Learn as extra credit. That exam would be the same format, would be only out of 100. So it would be the 50 questions, like your final, each 2 points. Your final would be each one 4 points for your final. And you only can take it once. But you have unlimited time for each question. You can use your materials, your book, your notes, class lectures, internet, anything you want. But you can just take it one time, so be careful. And anything that you get on that test, so for instance, say that you did your best, you get like 70 out of 100. I'm going to add 70 to your 800 as an extra credit. So this is a really good chance that if you have missed a quiz, if you did bad on like one of your exams and then you got 50, this is a good chance to compensate for that. Any question about that? And the deadline is before your final exam. And when you submit your questions, and the same thing for your extra credit assignments on BB if you press OK, you can see your grades, and I can see your grade. So please do that. Okay. Any questions? If not, I'm going to continue with the lecture. So we learned about writing Lewis structures for ionic compounds. For instance, I told you how we can do that for KCl. You write the electron configurations of K, and you know it's like in the first row, in the fourth row, and then first group, so it ends, in the valence you have like 1 electron. And then for Cl, we know it's in row 3, and then it's group 7A, so it should have like 3 S2 3 P 5 electron configuration. We have like 7 electrons. So what you do for K, you write like 1 electron. For Cl, you write 1 2 3 4 5 6 7. So K gives 1 electron to this, so it would be like K plus Cl minus. So this was for ionic compounds. So now we want to learn covalent Lewis structures, which are like electrons shared. So we said that if we have like covalent bonds, it means that the electrons are being shared between the atoms. And then we talked about molecular compounds in chapter 5, remember? Molecular covalent bonds. Okay, now let's see how to do it. For instance, water. We know water formula is H2O, right? So for H, we know it's in group 1A, so, and then it has 1 electron, right? It's 1s1. For oxygen, we know that we are like in row 2, and then group 6A, so you should have like 6 electron, 2s2, 2p4. So for hydrogen, you put 1 electron. For oxygen, to 1 2 3 4 5 6, right? And now you see that why we have H2O, because we have like 1 electron here and then 1 here, and then we should have another hydrogen, that this guy, kind of like share bonds with the other atom. So the resulting is like HOH. So 2 2 2 2. So these ones would be 1 bond, these ones would be 1 bond. So how we write it is that so H2O. And when you want to, kind of like what I wrote here, you have like oxygen, and then the ones that are like lone pair electrons or non-binding, we put those in front of each other. And then water has a bent structure, but for Lewis structure we don't consider that, we just write it as such, H2O. And now, if they share electrons, so now the number of electrons for oxygen would be 1, 2, 3, 4, 5, 6, 7, 8. For hydrogen, the number of electrons would be 1, 2, 1, 2. Let's do another example. For instance, if we talk about like Cl2, like Cl, again, we go to the periodic table, we see that Cl is in row 3 and group 7a. So it should have like 3s2, 3p5. So you have like 7. 1, 2, 3, 4, 5, 6, 7. And then you see that they have 1 lone pair electrons or non-bonding electrons, So we write 1, 2, 3, 4, 5, 6, 7. So now these two share these electrons, and then we became octet. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And now we have also triple, so these are like single bonds. You just see one bond. We also have, atoms can share 2 pairs of electrons. We call them double bonds. So double bonds are when 2 electron pairs are shared between 2 atoms. What that means is that, for instance, if you want to write the Lewis structure for O2, for oxygen, again, you can say that it's group 6a, so it should have like 6 valence electrons. 1, 2, 3, 4, 5, 6, right? And then 1, 2, 3, 4, 5, 6. Again, it's easier to write, kind of like, if you want to have a bond between these two, have the electrons that are not paired separately. So what happens? Like oxygen share these two and these two. So how can we write that better? Like this. So this would be the electron structure, Lewis structure of O2. So they have double bonds. Let's do for N2. They can also have 3 bonds, like N2. So what is triple bond? Triple bonds are when atoms share 3 electron pairs. Meaning that nitrogen. Can anyone tell me what is number of valence electrons for nitrogen? It's in group 5a. So it's 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now these atoms share these ones. So the better way of writing this would be like any question about this? So now, if we want to write Lewis structures for polyatomic ions, so for instance, imagine I want to write Cn minus. Can anyone remember what was the name of Cn minus, considering the fact that it didn't ask you to memorize polyatomic ions, but can anyone tell me? Cyanide, right? So you write C4, right? It's in group 4a. What about nitrogen? 5a. 4, 5. And now it has gained 1 electron, as if like carbon got 1 electron. Now we do the same. Or like NH4 plus. So we write for nitrogen 3 4. So NH4 plus has, for N we have this, for hydrogen we have this, right? And then we have 4 of that, and it has lost 1 electron, so kind of like erase 1 electron here, right? So the easiest way here is like, for hydrogen we have 5 1 2 3 4 5 for each hydrogen, like 1 electron. So it has lost 1 electron would be like this, NH4 plus. And then we have also exceptions to the octet rule. It means that, for instance, if you want to write, electronic configuration for NO, you can have like 1 2 3 4 5 for oxygen, 1 2 3 4 5 6, right? And then if I'm going to pair these, I cannot quite do that, right? It's kind of like, this is kind of like the best I can do. But if you count the number of electrons, 1 2 3 4 5 6 7, 2 3 4 5 6 7 8, but nitrogen, does not reach octet. Or if I want to do it for like BF3, so boron has like 5 1 2 3 4 5, F has like boron has like 3 valence electrons, 1 2 3, and then F3 it has like 7 1 2 3 4 5 6 7, 3 4 5 6 7, 1 2 3 4 5 6 7, and then you see that boron, it just has like 6 electrons. So there are exceptions, and the same thing, for like SF6. If you want to write the configuration, it would be like 1 2 6, 1 2 3 4 5 6, and then for F6, 2 3 4 5 6 7, 1 2 1 2 3 4 5 6 7, 1 2 3 4 5 6 7, 1 2 3 4 5 6 7, 1 2 3 4 5 6 7, 1 2 3 4 5 6 7, 1 2 3 4 5 6 7. For this would be 1 2 3 4 5 6, but it's kind of like it has 12. These are like expanded octets.